Hi there, I'm Sandhya from SAP. So today from the Duke University, the next project which is given is managing ML projects. The industry problem space which I have chosen for this project is aerospace. Because it is very close to my heart and I've been working with the aerospace for quite some time now. So what is the problem statement I've chosen is to predict the maintenance requirements for the aerospace engines to prevent unexpected failures and optimize the maintenance schedules. So there is always this problem in aviation wherein we have to give a predictive maintenance so that there is less of maintenance activities during the course of flight. So why is this an opportunity for ML case? This is obviously an high impact because once you have the accurate predictive maintenance, you can reduce the downtime, you can improve safety, and you can also, the major one is also cost savings, which is very important for the aviation industry. Feasibility, data on engine performance, and also the some historical data is also what we can get easily. So it is quite feasible to have predictive models for aircraft engines, and actionability or viability is early detection of these maintenance needs, which will allow us, operational efficiency at the end of the day. So from the business understanding of CRISP DM process, what we learned, the problem definition is really to predict the maintenance needs for the aerospace engines to prevent failures and optimize the maintenance schedules. The success metrics here around the data points, the data split and the data gathering will be around uh, some of the relevant data which I've mentioned, like equipment usage patterns, historical maintenance data, environmental data. So this has to be um, thoroughly studied and categorized so that we have the business outcome metrics such as accuracy of maintenance production predictions, and also reduction in the unexpected failures, which will again lead to some downtime and aircraft on ground kind of situations. Output metrics, here if we say frequency of maintenance alerts, so usually if there is a maintenance coming up in next 4 months, then we get an alert. So this can be very well triggered along the data model which we are creating at certain intervals. And also the maintenance planning lead time is significantly reduced when we are very ahead planned based on such kind of data. So this is the business understanding on how the ML case here can be applied to solve the predictive maintenance problem. So what is the plan? The solution concept is to develop the machine learning model for the predictive maintenance based on the historical data and also environmental data. Validation approach, we have to do some iterative experiment, of course, on training the models based on the historical data, testing procedures, demographic locations, maintenance needs, and it also differs from aircraft to aircraft on which the aircraft engine is fitted to what kind of aircraft and things like that. So what is the design or the model which we can select here for the algorithm is a time series data analysis and also anomaly detection in some cases, because what we're looking at is predictive maintenance, right? So we have to also check around in the history when and where it was an issue for this engine, right? Feature engineering, this will include all the relevant features which are related to the engine age, usage hours, or environmental factors, whatever can come into consideration. Model evaluation is we have to implement this in an iterative process. Of course, this is a robust evaluation strategy which we can use to assess the model performance and ensure real world application. But there are also potential risks which can happen. It is discrepancies in the training data, and we know about the data drift, changes in the engine behavior over time, and it may lead to the model degradation over time. So we have to come up with monitoring concepts as well. Latency delays in maintenance can happen, that can affect the operational efficiency, and concept drift also, which may require model training for accurate prediction. With this, I rest my case, and thank you for reviewing this use case.